Ladies and gentlemen, good afternoon. We are beginning the panel session of the Dissertation Board. It's a doctoral thesis by Filipp Chetverikov. The specialization is 030204, Zoology. The topic is Trends in the Evolution of Eriophyoid mites on plants. The board was set up by Rector's order. I'm Andrei Granovich, who was appointed chair of the Dissertation Board. Allow me to introduce members of the Dissertation Board. Kirill Koloktionov, Doctor of Biology, Professor of the Invertebrate Zoology Department. Sergei Mironov, Doctor of Biology, Zoological Institute of the Russian Academy of Sciences. Alexander Stikolnikov, Doctor of Biology, Zoological Institute of the Russian Academy of Sciences. Matvey Skorotsky has joined us remotely. PhD in Biology, Adam Mickiewicz University in Poznań, Poland. I hope we will not have any technical issues during the session. Under the federal law number 127, as of the 23rd of August 1996, on science and scientific and technical policy, St. Petersburg State University is entitled to confer academic degrees. The Dissertation Board is specifically for each defense, and I'd like to inform you on this agenda. It's a new format of defenses we have at St. Petersburg State University. Let me announce the agenda. I'll start with my presentation about the documents submitted for the defense for the candidate. Item 2, a 15-minute presentation by the candidate. Then questions to the candidate regarding his presentation. Then I'll provide an overview of external reports on the thesis. After that, all the board members will take the floor in turns to report on the thesis with the critical remarks, questions. After that, the floor will be given to the candidate to comment upon the critical remarks and questions of the board members. We'll also have a Q&A session. Any non-board member will be able to participate. I kindly ask all those willing to take the floor from the non-board members to fill in the special form and introduce themselves before they take the floor. This will be followed by a very important part of our session. I'll ask all the non-board members to leave the hall. Only board members will be present. After that, we will invite all the people back for the open balloting on the issue of conferring or non-conferring the academic degree. And finally, the candidate will be given time for his closing speech. The session will last no longer 2 hours. If there are mobile phones, please switch them off. Our session is being broadcast live and is being recorded. This is what I call feel-free. So I'm beginning with the agenda, and the first item on the agenda is my report on the documents submitted by the candidate. So the candidate has submitted the following documents to the SPBU Academic Secretary. List of published works containing 88 items, which describe the research findings, including 46 published in the Web of Science and Scopus Index journals, a diploma of the candidate of sciences in biology, and a thesis in Russian and English, a printed version with the manuscript copyright and a digital copy. The thesis formatting complies with all the necessary requirements. The above-mentioned documents comply with item 12 of section 3 of the relevant order of St. Petersburg State University. Now, I have to ask you, according to the agenda, if there are any questions regarding the documents submitted by the candidate. If there are no questions, then we are moving towards the crucial part of our today's session. This is the candidate's report on his research findings. 15 minutes.
Dear Chairman, dear members of the Dissertation Board, dear guests, the topic of my thesis is trends in the evolution of eriophyoid mites on plants. Mites of Eriophyoidea superfamily are obligate parasites of higher plants. They have an elongated body, a piercing and sucking mouth part, and only 2 pairs of legs. It is extremely relevant to study these mites because they can damage agricultural crops. The main feature of these mites is that their evolution is influenced by 2 major constraints. First of all, they are simple arthropod with a miniature size. Secondly, Eriophyoidea are characterized by a high level of specialization to phytoparasitism. The goal of the thesis is to examine the morphological and functional properties of 4-legged mites and to identify the major trends in their evolution. To achieve the goal, I have set up 4 objectives. I have examined the body plan of the 4-legged mites. I have reconstructed the base and divergence of the superfamily Eriophyoidea. I have identified the major evolutionary trends and analyzed the phylogenetic relations of Eriophyoidea with other groups of mites. I have collected material for the thesis, and I have been doing it for 25 years in Russia, Europe, North America and South Africa. My colleagues have sent me material from South America. I have also used material from some foreign and Russian collections, including the Kiefer collection and Nalepa collection. I have described 7 new genera and 16 new species of Eriophyoidea. To study the mites, I use different methods of light and electronic microscopy. I have developed a new method for dissecting the mites with the help of the laser microdissector, and I have described a new technique for studying the endocuticular structure of the mites on the confocal microscope. To study the anatomy and embryogenesis of the mites, I used the material marked by fluorescent dyes. The first chapter of the dissertation examines the body plan and the origin of the morphotype. The analysis that I conducted showed that these mites are different from the typological body plan. I have reconstructed the embryogenesis of Eriophyoidea. And unlike other mites, Eriophyoidea have a meroblastic cleavage.
I have also shown that
gall mites have the adlagars only on the first and of the second pairs of legs. The reduction of the third and of the fourth pair of legs is characteristic for other mites as well. For example, mites that parasite on different animals. However, the Eriophyoidea is characterized by the absence of two back pairs of legs. They have a wormiform body, which is quite rare among mites. The wormiform is characteristic of different mites that live in constrained spaces, for example, in land ducts or between the parts of the soil. However, only Eriophyoidea have a really wormiform body, while other mites have an elongated and flat body. Four-legged mites also have a unique structure of the muscula. And their musculature is very similar to the musculature of some fly larvae. Such musculature helps the mites to live in loose substances and to move in tunnels. It is obvious that this type of musculature was formed at a very early stage of phylogenesis in the ancestral environment. The analysis that we have conducted shows that the archetype of Eriophyoidea was formed in the intestinal environment. In the second chapter, I reconstruct the basal divergence of the Eriophyoidea, and they can be divided into two major clades, Phytoptide and Eriophyoidea. The two genera, Penticetacus and Loboquintus, which are marked by yellow on this slide, are different. The Phytoptoid clade includes two monophyletic groups, Nellipilide from coniferous plants and Phytoptide from flowers. The second clade includes Eriophyoid and Diplomites. The data that we have obtained shows that we should revise the overall system of this superfamily. The apomorphies that we have identified can be helpful in revising this structure. I would like to say that they have characteristic internal genitals and anatosomes. I have identified such characteristic features as spermathecal apparatus and genital epidermis. The major features for dividing different clades are the form of the spermatum, the length and the form of spermatic ducts, and the way of packaging sperm cells in the spermatheca. The second major group of traits was identified while I was examining the mouth parts. In different clades or Eriophyoidea, we can see different interlocking structures. In one group, structures on palps are used, and in other groups, we see hook form structures on the basal part of the calyces. I have also reconstructed the relation of the mites with different other types of higher plants. I believe that their development started in the Mesozoic
Связь
era, and
эрioфyoидеи
then
с
they
голосеменными была
transferred to
первичной.
gymnosperm and flower
Эволюция
plants.
фитоптоидной клади следовала дихотомии высших
And
растений на
the evolution of
голосеменные
the
и
phytopteroid clade
покрытосеменные.
reflected the
Формирование клада
dichotomy
эрioфит
of
происходило в
higher
связи с
plants.
бурным расцветом цветковых в
The formation
кайнозое.
of
При этом
eriophyoid
именно для представителей этой
was
клады
connected with the
характерны
development of
многочисленные
flowers in the
переходы с цветковых на
Cainozoic period,
голосеменные,
and it is this
папоротники
clade
и
that is
хвощи.
characterized by multiple transitions from flowers
Третий
to
раздел диссертации
gymnosperms and
посвящен
ferns.
анализу важнейших аспектов
The
эволюционной
third part
пластичности
of the thesis
четырехногих
deals
клещей.
with the
В
evolutionary
качестве таких
plasticity of
аспектов я
four-legged mites.
рассматриваю магистральные
Here I
морфоэкологические
examine
тенденции,
major morphological
наблюдающиеся
and
в эволюции
environmental
группы.
trends.
Мною выделено 10
I have
таких
identified
тенденций.
10
Они
trends.
включают
They include
преобразование
changes in the
гнатосома,
gnatosome,
конечностей полового
hetome,
аппарата,
legs and genitals,
трансформации экзоскелета,
transformations of the
модификации
exoskeleton,
жизненных
modification
циклов,
of life cycles,
освоение новых ниш и индукцию
living
галогенеза,
in new environments
криптическое
and induction
видообразование и
of
формирование
gologenesis,
вторичных
cryptic speech
эволюционных каналов.
formation, and the formation of secondary evolutionary channels.
В ходе формирования симбиотических отношений с растениями
In symbiotic
четырехногие клещи
relations
приобрели
with plants,
способность индуцировать галлогенез.
four-legged mites
Галлы
induce
эрioфyoidеи – это
galls. The
новообразования,
galls of
возникающие в тканях
eriophyoidea
растений
are
под
growth
действием
abnormalities
клещей.
which are
На
formed
примере
on
модельной
plants
системы
under the
нами
influence
были
of their
рассмотрены
saliva.
изменения,
I
происходящие
have
в тканях
examined the
листа
changes
в ходе
in the
образования
tissues of the
галлов.
plants.
Моделью послужили галловые
The
клещи
model
рода Фрагариопутес
was the
на землянике.
gall
Было
mites
выяснено, что в
that
зоне
live
роста
on
галла происходит
different
патологическая
plants.
инверсия гистогенеза, когда в
Here we
дорзальной
see the
части
pathological
листа
inversion
формируются
of
ткани
histogenesis
вентрального типа.
when ventral
Генетический анализ
tissues
показал, что
are formed
влияние
in the
клещей на
dorsal part
развитие
of the
листа
leaf.
осуществляется через изменение
The-
уровня экспрессии
Here we
генов,
also see the changes in the gene expression, I mean the genes that regulate the synthesis of cytokinin and regulating genes.
Таким образом,
Therefore,
нами было
I have
установлено, что галловые
revealed
клещи
that
искажают
gall mites
нормальный морфогенез органов
change the
растений,
normal
запуская уже
morphogenesis of
имеющиеся в геноме
plants,
хозяина программы развития,
and
тем
therefore
самым манипулируют
they manipulate
процессами роста
the
и
growth
дифференцировки
process
в
and the
растительных тканях.
differentiation process in the plants.
На морфологическом
At the
уровне
morphological
клещам,
level,
способным вызывать рост
mites
галлов,
that can
близки
induce
впервые
galls
обнаруженные нами эндопаразитические формы
are
эрioфyoидеи.
close with
Например,
endoparasitic
клещи
forms
рода
of
Novophytopus,
eriophyoidea, for
живущие
example,
внутри листьев осок и
Novophytopus
злаков,
mites
или клещи
that
рода Tricetacus, живущие внутри
live in
игл
rushes or
голосеменных.
carex.
У таких клещей удлиняется
Such
опистосома
mites
и
have an
усиливается
elongated
роль локомоции за счет
opistosoma
изгибания
and
тела.
have a curved body.
Противоположная тенденция
There's a
наблюдается при
reverse
переходе
trend,
к бродяжничеству
which we
и
see when
жизни на открытых поверхностях
mites start to
растений.
live
Свободно
on open
живущие
parts of
эрioфyoидеи
plants.
обычно имеют компактное
Free-living
тело и
eriophyoidea
быстро
have a
бегают по
compact body
поверхности растений.
and can run
Для таких
fast
клещей
on
характерна
plants.
консолидация
They're
тела
characterized
путем
by consolidated
топографических
body,
трансформаций экзоскелета,
by transformations of the
олигомеризации
exoskeleton, by the
опистосомальных колец и
oligomerization
образования
of the
псевдотап
opistosomal
путем слияния
annuli,
колец опистосомы.
and so on.
Представленные примеры
The
это предельные
examples that I have
случаи
shown
единого
are
процесса
the extreme
адаптивного
cases of the
формообразования в
process of
подсемействе
adaptation
Eriophyoidea.
in the superfamily
Анализ
of
обширного материала
Eriophyoidea.
показывает,
My analysis
что
shows
эволюция четырехногих клещей
that
происходили
during the
многочисленные
evolution
реверсии
there
формы
were
тела,
multiple
от
reversions of their
червеобразной
body
к
form,
компактной
from
и обратно.
vermiform to compact and
Основой
back.
для реверсии послужила двойственность
It is
планостроения
based
эрioфyoидей, поскольку
on
для
the
этих
fact
клещей
that
характерно
the mites
одновременное сочетание
combine
двух типов
two types of
локомоции.
locomotion,
Ползание наподобие
moving
червей,
like,
бег, как у
like
бегущих
worms
животных.
and moving like
Пластичность в
running
отношении типа
animals.
локомоции и общего габитуса определили успешность
Therefore,
эрioфyoидей в
the
освоении
eriophyoidea
разнообразных ниш на растениях.
can live on different plants.
Наряду с морфологическими реверсиями в
In
эволюции
my
четырехногих
thesis,
клещей наблюдается
I
феномен,
have also
который мы
described
обозначили
the
как
phenomenon
формирование
which I call
вторичных
the formation of
эволюционных
secondary
каналов.
evolutionary channels.
Известно, что эволюционный
The
процесс в силу
evolutionary
возникновения разнообразных
process
запретов в определенной
is
степени
characterized by
канализован.
different
При этом
constraints, therefore
канализованность
it
особенно
is in a way
характерна для
channelized.
высокоспециализированных
The
паразитических
channels in
организмов,
evolution
в
are
частности
characteristic
эрioфyoидей.
for different parasitic organisms.
можно назвать канализованностью первого
And
порядка.
this is the
В
channels
силу
of the first degree.
гомопластичной природы и
Due to the
большинства
homoplastic
морфологических признаков
nature
четырехногих
of
клещей,
different
в их
morphological
эволюции
features of the
формируются
mites,
каналы
we can
второго
also
порядка.
identify
На
the channels of
таксономическом
the
уровне этим каналам соответствует
second
несколько
degree, the
крупных
so-called secondary
полифилетических
channels.
кодов, морфотип которых регулярно
Here
воспроизводится
I
в
mean that
эволюции.
the
В
morphotype
итоге
of some
эволюция группы
genre
предстает как колебательный процесс
reproduces
относительно нескольких
during the
условно
evolution.
равновесных
In other
состояний.
way,
Когда в
or in
результате
other words,
морфологических
we
реверсий
see
происходит
the
регулярное
so-called
отклонение и
oscillation
вновь
between
возвращение
different
в русло
balanced
вторичных каналов,
states
своего
in
рода
the evolution.
осцилляция. Заключительный раздел диссертации посвящен проблеме происхождения
The
галловых
last part of the
клещей.
thesis is devoted
Согласно
to the
доминирующей в
origin of gall
настоящее
mites.
время гипотезе,
According to the major
эрioфyoидеи
hypothesis,
входят в
eriophyoidea
когорту
are
Eupatides
included
и
in the
находятся в
cohort of
сестринском родстве
Eupatides
с тидеоидными
and they're in
клещами.
sister relationship
Нами
with
получены новые
Untitled
данные,
mites.
говорящие о родстве
I have
эрioфyoидей и
obtained the data
червеобразных
which
почвенных
proves that
клещей и мотылиц.
eriophyoidea are in relation with soil mites of
На данном
nematoliths.
слайде показана
On this
кладограмма,
slide, you can see
полученная
the
в ходе
cladogram,
клавистического анализа морфологических признаков клещей.
which was obtained
Анализ
after the
показал, что
morphological analysis
эрioфyoидеи не
of the
входят
mites.
в состав таксона Trampidiformis. При этом
And
вместе с
you can
червеобразными
see
почвенными
the position
мотылицидами
of the
они образуют
eriophyoidea
высокоподдержанную кладу EN.
in this clade.
Эта клада входит в состав парафилетической слабо разрешенной группы Sarcoptiformis. Независимая проверка этого результата была проведена в ходе молекулярно-филогенетического анализа.
Proved my
В анализ
assumption,
были включены
and I
все
conducted
основные
a
линии
molecular and
бактериоформных
phylogenetic
клещей, а
analysis.
материалом послужили частичные
I used
последовательности 6
genome
генов из
sequences
двух
of two
групп:
groups,
гены ядерных рибосомальных
nuclear RNA
РНК
genes
и белок-кодирующий
and
ген.
protein genes.
На дереве по ядерным белковым генам
And
эрioфyoидеи
here
вошли в
you
слабо
can see
поддержанную
that
кладу
according to my
стеопатии.
molecular phylogenetic
Однако на
analysis,
итоговом дереве,
the
построенном
assumption
по всем
about
6
the
генам, так же, как и на дереве,
relation between
построенном по
eriophyoidea
рибосомальным
and
генам,
soil mites
выявлена высоко
turned out
поддержанная клада EN.
to be true.
Таким образом, гипотеза о родстве эрioфyoидеи с
Therefore,
мотылицидами
this is the
получает
major
наибольшее
hypothesis
подкрепление и становится лидирующей.
in my opinion.
На этом
On the
заключительном
last slide,
слайде представлена
you can see
схема,
the
отражающая
layout
нашу
which reflects my
гипотезу о
hypothesis
происхождении
about the
четырехногих
origin of
клещей.
eriophyoidea.
Эволюционная траектория,
The
которая
evolutionary
привела к формированию
trajectory
эрioфyoидея, начинается от
starts with
слабоспециализированных
weakly specialized saprotrophic and acariform mites.
Возможно, они обитали
Probably
в
they
почвенной
lived
подстилке
in soil
палеозойских
in
лесов.
Paleozoic
Переход к
period.
обитанию в туннелеподобных
Then they
пространствах
started to
между
live in
частицами
tunnels
почвы
between
и
the parts
питанию
of the
почвенными
soil and
микробами
started to
привели к формированию общего предка современных
feed off
нематолицид и
soil
эрioфyoидей.
microbes.
В случае с нематолицидами
In
основным
case of
эволюционным
nematolithide,
трендом стало
the major
освоение глубинных
evolutionary
слоев
trade
почвы.
was the living
Становление же
in lower
эрioфyoидей
levels of the
сопровождалось
soil.
переходом
As
к
for
фитофагии.
eriophyoidea,
При этом,
these mites
возможно, оно шло через стадию
transferred to
питания компонентами
phytophagy.
микоризы
Probably
или
it was
бактериальных
preceded by
колоний на
feeding
корнях
of
растений.
bacterial colony on roots.
Выводы представлены на данном
You can see
слайде.
the
Я их
research
распечатал
findings
и
on this
раздал.
slide. I
Разрешите
have
выводы не зачитывать.
put them on the handout, so I will not read them out. Thank you. Colleagues, are there any questions about the presentation? Are there any questions? Please take the floor. I will repeat. I'm from the Russian Academy of Science. So you have shown us the layout of the channels of the evolution. You spoke about the first and the second channel. Could you please clarify this slide, because I didn't quite understand.
Сложенные системы.
These are systems, one inside another.
Линии, эволюционирующие как паразиты,
I can
она
say that
ограничена. Это канал первого порядка.
the
Вот они
channel
вступили
of
на
the
него,
first
и внутри
degree
него
means that
формируются
the
как вторичные каналы.
mites undergo evolution within one channel, and the secondary channels are formed within this first channel. I asked this question because I did not quite understand the picture on your slide. There was an inconsistency, but now everything is clear. Are there any other questions? I would like to ask a question. You are examining the morphological structure and you speak about the miniature size. But can we say that this is the retardation at the larva stage, when some organs are reduced, which is often the case? Well, this issue is widely discussed in literature, and according to Soviet literature, your opinion is the leading one. For example, Lange and Shevchenko shared your opinion. But in foreign literature, the opinion is different. Lindqvist from Canada states that this is the trend for the miniature size. And he gives the following argument. If they were neotonic organisms, then they would be the pre-larva of Acari forms, but they would be consistent with an even earlier stage. I believe that it's quite difficult to imagine such a situation within this taxa, so I decided to ignore this hypothesis and to brush it aside. Any other questions? Matei, do you have a question? Then thank you for your answers.
We will now be focusing on reports. These are external reports as well as reports of the board members. I'll start with external reports. We have quite many of them. There are 7 of them. I will state the name of the person who submitted an external report and the organization they represent, and I will read out some remarks. There is not a lot of criticism there. The first report is from Dr. Charny Kramer, senior researcher specializing on biosystemics of Eriophyoidea, Eriophyoidea Biosystematics Agricultural Research Council.
I could find no major fault with the results, interpretation, and personal error. I found the typing and spelling errors in English translation somewhat irritating, but it definitely doesn't negate the excellence of the content. I strongly recommend accepting this dissertation for the defense, and after oral presentation and discussion to award Dr. Chetverikov with the title.
The next report is from Professor Boris Krasnov. It's the Benislow Chair for Wildlife Management and Conservation.
Be a template for the studying other taxa of microscopic animals. The study resulted in multiple publications in international periodics. I have no doubt that Chetverikov deserves the degree of Doctor of Biological Science. Отзыв от профессора Азман Салливан.
The next one is from Professor Dr. Sebat, Faculty of Agriculture, Department of Agriculture. Я понимаю, что соискатель — это большой специалист в этой области, и его работа делает вклад в наше общее дело, которое мы ведем на двух континентах. Схема проведения исследования, его дизайн могут служить моделью для дальнейших исследований подобного рода. The next report is from Professor Radmila Petanovic, corresponding member of Serbian Academy of Science and Arts, University of Belgrade. Хочется отметить высокое качество иллюстраций и фотографий, которые соискатель выполнил сам. Диссертация является важным вкладом в понимание эволюции четырехногих клещей. И я выступаю за присуждение степени доктора биологических наук. И я уверена, что Филиппу Четверикову будет присуждена искомая степень. The next report is from Dr. Geza Ripka, National Food Chain Safety Office. It's the only report with a question. Давайте сравним результаты вашего классического анализа с результатами исследований Конго и Джана, 1996 год. Ваше мнение о таксономическом положении рассматриваемой семьи в надсемье Eriophyoidea. Качество публикации и качество диссертации мне представляется очень высоким. Я рекомендую присудить соискателю искомую степень. The next report is by Sagdiana Sukhareva, candidate of Biological Sciences from St. Petersburg State University. I should highlight that all the data and materials have been already published by the candidate. It was interesting, it was quite easy to read the thesis. I used to be the academic council of defense board, and I consider this dissertation to be a unique practice because it contains almost 100 pre-published data. Последний отзыв от профессора Сара Жуков. Впечатляет объем данных, проанализированных соискателем. Эта задача была непростой. Следует продвигать результаты его исследования в научном сообществе. И я надеюсь на сотрудничество с Филиппом Четвериковым по проблематике четырехногих клещей. Let me also add that all the reports were duly submitted and uploaded on the SPBU official website. We are moving forward, and I'd like to specify that answers to questions and your comments upon the critical remarks are welcome after we have read all the reports. Colleagues, we are now proceeding to the next item on our agenda, and these are reports by the board members. Александр Стекольников, welcome.
Уважаемые коллеги, работа диссертанта замечательна как по широте объему проделанной работы, так и по множеству аспектов рассмотрения предмета. Морфология, причем не только классическая внешняя морфология, но и серьезно улучшенные реформированные методы изучения внутренней морфологии, трехмерной реконструкции, молекулярная филогения, изучение эмбриологии, описание новых таксонов. Ну, такая широта, она, возможно, обычна в исследованиях в рамках зоологии беспозвоночных, но что касается акарологии, ну и, пожалуй, энтомологии тоже, это, в общем, мне кажется, достаточная редкость. Результаты диссертанта, несомненно, вносят выдающийся вклад в изучение этой очень большой группы. Я подчеркиваю, здесь около 5000 видов четырехногих клещей. И, как мы видим, они достаточно хорошо признаны международно. Это все опубликовано в международных журналах, вот, в том числе довольно высокого уровня. Теперь по поводу, ну, несомненно, что как квалификационная работа этот труд, ну, больше, чем достаточен, и диссертант, несомненно, заслуживает искомой степени. Теперь по поводу некоторых замечаний, которые я хотел бы сделать. Сама структура работы имеет некоторые недостатки, вот, поскольку возможна ее публикация, как я понял, в качестве монографии отдельной, вот, это может иметь значение. Ну, во-первых, таблицы и рисунки вынесены в приложение. Это довольно неудобно, заметно затрудняет изучение работы. Отсутствует полностью раздел материала и методики. И из-за подробного описания методик автор отсылает читателей к разным публикациям. Это недостаток, это довольно неудобно, вот, и серьезно мешает изучать работу. В главе 1, которая посвящена плану строения эрiophyoidei, есть следующие спорные моменты. Необоснованное утверждение о том, что участие щетинок в локомоции и расселении – результат адаптации к жизни на растениях. Это возможно и вероятно, но я не вижу обоснования. Во 2 главе, которая посвящена построению филогении и ревизии системы, присутствует странное утверждение о том, что система Эмрайна, несмотря на использование гомопластических признаков и признание априорно пара- и полифилетических таксонов, позволяет все же успешно определять эрiophyoidei до рода. Ну, каким образом признание парафилетических таксонов могло бы помешать успешно определять экземпляры до рода? Это совершенно разные функции системы. Надеюсь, что автор просто неудачно выразился. Дальше. Ну, упомяну еще досадную опечатку, в результате которой на 79-й странице имеет место отсыл совершенно не к тому разделу работы. 2.4 вместо 4.
For example, he makes reference to
Самая серьезная, на мой взгляд, проблема связана с 4
item, which is not correct. The major drawback is in the 4th chapter.
Два основных положения – родство эрiophyoidei с
The
нематолицидами
two major
и
assumptions, the
интерстициальный образ жизни
interstitial
протоэрiophyoidei,
environment and the relation with soil mites are not substantiated. Number one, you have taken 50 taxa for the morphological analysis against 198 taxa for the molecular analysis. And therefore, I believe that the material is quite limited and subjective. Besides, you do not substantiate the choice of some groups of mice. Therefore, I cannot say that the research findings of the morphological cladogram are reliable. The molecular and phylogenetic analysis shows that there are some competitive hypotheses. H1, eriophyoidea are part of trombidiform mites, and H1, eriophyoidea are not part of trombidiform mites, and H4, according to which eriophyoidea are in relation with nematolicide. And these hypotheses are supported by different types of genes. H2 by protein genes and H1 and H4 by RNA genes. So when you conduct the analysis with the whole set of genes, I
от
believe
факторов, которые
that
случайны в
the
данном контексте. Ну,
results
например,
of
числа и
such
состава
research
генов в
depends
первой и второй
on
группе.
different random
Таким образом,
factors.
вывод об большей вероятности
Therefore,
родства эрioфиидей с
your
нематолицидами,
research
который сделан
finding
на
that
основе вот этого
eriophyoidea are in
суммарного
relation with
анализа, не является
nematolitide
обоснованным, должен быть
does
ответ.
not seem reliable.
Третье, червеобразная
Number
форма
3,
тела,
the
колющийся сосущий
wormiform
ротовой аппарат,
and
как
sucking
отмечает
piercing
диссертант,
mouth
могли
part
сформироваться у
could
протоэрioфоидей
have been formed
либо как
as
приспособление
an
к интерстициальному
adaptation,
образу
as an
жизни, которые ведут
interstitial way of life,
червеобразные нематолициды, либо в
or
связи с
in
тканевым
connection
паразитизмом,
with
как,
the
например, у
tissue
гемодицин. И
parasitism.
первому варианту он отдает
And the
предпочтение, потому
candidate
что считает
thinks
эрioфит
that the
родственными
first
нематолицидам. Во-первых, мне
assumption
кажется, это логическая
is
ошибка,
more
потому что
appropriate,
особенности
but I
морфологии,
believe
которые
that
явно
there's a
связаны со
logical
средой
mistake
обитания,
here.
не требуют для своего
The
объяснения
morphological
эволюционного родства.
structures
Точно
do
так же, как
not
сама
need
общность
any evolutionary
среды обитания тоже этого не
relation,
требует. Вот. Ну и
as
во-вторых, родство эрioфит и нематолицид,
the
как я уже
habitat
отметил,
is
мне
not
кажется,
appropriate here
необоснованным. Вот, то есть
and
в целом вот
not
эта
substantiated
схема
either.
эволюции эрioфоидей,
So the scheme of the evolution
диссертант, она возможна.
is possible, I believe. I cannot say anything against it,
Каких-то данных, которые
but I do not see any data that can prove this evolutionary trend. I believe these are just the candidate speculations.
позвольте закончить, я уже сказал, что в целом
So,
работа, безусловно, выдающаяся.
I have just said this is a superb thesis, but there are some controversial issues here.
Филипп Евгеньевич, вы зафиксировали, да, все это?
I believe that you have taken notes.
Так, и я теперь хотел бы предоставить
Now,
слово Сергею Валентиновичу. Пожалуйста, для
Диссертационная работа Филиппа Chetverikova посвящена
This focuses on major trends in the evolution of eriophyoid mites on plants. It's one of the major groups. Acariform group is the biggest one which settles on plants. I will not speak at length about the theoretical and practical value about this work. The general quality of this work is high. He has made a major contribution into understanding of this group and its evolution. He has set all the major trends in the evolution of this group of mites. He speaks about the body plan of mites, focuses on specific parts of their body, their morphotypes are described, and their life cycle is also in the focus. He has developed and implemented new methods of studying morphology of mites. Filipp Chetverikov has obtained new data on morphology and ecology of Eriophyoidea. He has also established some regularities in their evolution, which allowed, in its turn, to better understand its adaptive features. This data is valuable. It will be applied for the development of methods to control their population. Talking about the structure of the thesis, I have some questions. There is no dedicated chapter or a section that focuses on methods and materials. Some data on the materials is provided for in the introduction. Then, along the thesis, he makes references to different prior publications he made. It impedes understanding of the thesis. The first chapter focuses on the body structure of Eriophyoidea. He writes about their miniature size and possible adaptations and pre-adaptations to phytoparasitism. There are some dubious assumptions when he discusses possible factors which influence their modification. One of the assumptions is only in Eriophyoidea's reduction of the two posterior pairs of legs is combined with variform body shape. This is not really true. Some other species show the same specifics. He also states that data on the opisthotomal musculature and eriophyoid suggest that dorsal and ventral parts of these segments were reduced to a different extent. There is nothing new here. In all major manuals on biology, we see these facts. It's not very clear for me how the digits work, because that's true for many species which have the piercing, sucking mouth part. It's not really clear how this piercing and sucking takes place, which muscles are used here. The first chapter focuses on phylogenesis and the taxonomy of Eriophyoidea. He writes about the current issues in this system, some unclear points, and discusses morphological markers of basal lineages. Here I don't have any questions, apart from one critical remark. Almost all formal characteristics of cladograms, as well as the materials and methods, are not explained in this chapter. It's a structural drawback of the thesis. The first chapter is about morpho-ecological aspects of evolutionary plasticity of Eriophyoidea. It's a crucial part of the study. He writes here about the consolidation of the body, modification of separate body systems, and their life cycles. Different lifestyle strategies are discussed, such as gallo formation and endoparasitism. Here we also have some disputable issues. The gallo-induced nobility has evolved homoplastically in various lineages of Eriophyoidea. Moreover, there are reasons to believe that this ability has also been lost many times and acquired again, as the candidate states. He also writes that the loss, as well as the acquirement, could theoretically have happened even within a single generation in mite population. I think it's a very brave statement to make. I believe this might be due to the poor choice of morphological features in the first place. It's a very subjective evaluation of ours. Maybe for the mites themselves, the number of features is enough. He also writes about the secondary or second-level evolutionary channel. Maybe this is just an improper wording. Maybe he got lost in terminology. The channels, he writes, are represented by several large polyphyletic genera, with the morphotypes commonly reproduced in evolution of Eriophyoidea. Further in the dissertation, he regards them as the morphotypes. It's a terminology issue, I suppose. If it's not possible to visually understand which set of factors resulted in this or that phenomenon, then you could have applied cladistic analysis in this case. The last chapter focuses on the early stages of Eriophyoidea. He makes an assumption that they have similarities with nematolithid mites. These are soil and sand mites. Here he focuses on the hypothesis, which is then evidenced by the data he collected.
гипотезу о родстве эрифидей с
The most important factor
червеобразная форма тела и колющий сосущий бытовой аппарат.
that provides evidence for the relations with
Формировацию предков этой группы
soil mites is their vermiform body and piercing and sucking mouthpart.
теоретик тканевому паразитизму на растениях. Однако против этого можно высказать следующие соображения.
I have something against here.
Эрioфии, по-видимому, отсутствовали какие-то
First off, I believe eriophyoids lack any kind of mechanism to pierce tissue.
примитивным колющим аппаратом весьма это, видимо,
With the primitive piercing mouthpart, it was difficult to do that. Some advanced species of mites can penetrate tissue. Secondly, to penetrate into tissue of plants, mites have to be really small in size. And vermiform body could arise convergently due to their original lifestyle in leaves and folds of plants. Very often, this piercing and sucking mouthpart
заключение диссертации
is a result of liquid food.
кратко и лаконично суммированы остальные результаты и основные положения.
In conclusion, he provides a sum up of the results of the study. Despite all the minor drawbacks, this dissertation is a robust study and it makes a big contribution into the relevant field. Thank you.
Now the floor is given to Professor Galaktionov. Dear colleagues, the other members of the dissertation board have made my task easier because they have analyzed the thesis. So I'm not going to read out the thesis, I will just highlight some important issues. First of all, I would like to say that this is a diverse study. The candidate for the degree has demonstrated his ability to use a wide spectrum of methods, including modern ones. The dissection of mites, the different methods of microscopy, the transcription analysis, and so on. So this is a very diverse study, and the candidate for the degree is a specialist who can use different methods. And I think this is one of the merits of the thesis. I also want to say that he has given a good review of theoretical works. And in the introduction, he sets up the 4 tasks and he is able to achieve all the objectives of the thesis. The thesis, I think, is also relevant because the mites he's studying have not been sufficiently studied. They are miniature in size, but they are very widespread. Moreover, they can damage agricultural crops. Therefore, I think that the thesis is relevant. We should not forget about their ability to expand different plants and different areas. I must agree that the miniature size and the simplification of their structure is one of the major trends in the evolution. As a result, we have a limited set of morphological traits which change in different taxa. But since this set of features is quite limited due to the miniature size, there are some difficulties in differentiating different taxa, as well as in differentiating different genera. Although this is true for different other types of parasites which are characterized by miniature size. But in my opinion, the thesis is very logical, including the assumption that the high specialization happened in the interstitial environment, and after that the mites transferred to phytoparasitism. This assumption seems relevant and logical. In the thesis, he analyzes the evolutionary trends. He speaks about the modes of evolution or aspects of evolution, and here I think that he should have used one term instead of two terms, because the use of different terms might confuse the reader. The candidate writes about the secondary evolutionary channels. This is quite an interesting issue in the thesis, and here we see some logics. So the simple morphological organization allows us to have a line of similar forms. And here we should recall that Eriophyoidea are adapted to sucking liquids from plants, so they are not limited in the resource that they should get. Therefore, the use of one morphotype allows them to start living on different plants, including non-relative types of plants. Brooks-Hoberts describes this concept as the concept of false liberalists. And I'm not going to go into detail here. The candidate writes about the relations of Eriophyoidea and different other groups of mites. What I'd like to highlight here is that endoparasitism can be an environmental reversion, the adaptation to living between different parts of soil. In my opinion, this is hardly possible. I don't think that this is a reverse trend, because changes and shifts between different types of parasitism is characteristic of different types of parasitites. If we recall other types of mites, we see a similar picture there. We see such shifts from one type of parasitism to some other type of parasitism. In general, the thesis is highly valuable. He has published a lot of papers which reflect the research findings, and he has published articles in major journals, including international journals, which proved that his articles were reviewed by major specialists in the area. And it means that they assessed positively and highly his work. Therefore, I believe that Mr. Chetverikov should be awarded the academic degree of the Doctor of Biology. Thank you.
Now the floor is given to Maciej Skorotsky. You're welcome to take the floor. Большое спасибо за предоставленную возможность. I'm sorry that I will be using English. Unfortunately, my Russian is not that good. Уважаемые присутствующие, позвольте огласить мой отзыв. Это отзыв на диссертацию Филиппа Четверикова. Фокус здесь на направлениях эволюции четырехногих клещей на растения. Четырехногие клещи — это группа, которая оказывает влияние на экономику, потому что она вызывает аномалии в растениях и передает вирусные заболевания. Таким образом, исследование Четверикова позволяет нам глубже понять то, как функционируют, эволюционируют и живут четвероногие клещи. Диссертация была подана на соискание степени доктора биологических наук. Цель диссертации — это ответить на вопрос, какие черты позволяют четырехногим клещам адаптироваться к новым условиям, каким образом происходит их эволюция. Чтобы ответить на этот вопрос, автор поставил несколько целей. Например, одна из них — это анализ строения и конструкция филогенезиса, анализ растений хозяев, ассоциируемых с этой группой клещей, описание ключевых морфоэкологических тенденций, влияющих на их эволюцию. Эти цели все соответствуют тематике исследования. Соискатель использует огромное количество современных методов исследования, как световая микроскопия, конфокальное лазерное сканирующая микроскопия и так далее. Эти методы мне представляются достаточными и актуальными. Структура диссертации соответствует всем принципам и всем требованиям, которые предъявляются к работам подобного рода. Эта диссертация — это пример многостороннего исследования группы микроскопических беспозвоночных фитофагов. Соискатель получил новые данные по разным областям знания: сравнительная морфология, филогенезис, эмбриология, галообразование. Данные показывают, что маленький размер клещей и морфологическое упрощение является очередным витком эволюции. Холистические методы позволяют установить соотношение между эрiophyoidеями и почвенными нематолицидами. Это говорит о том, что акариформные клещи, переходя к интерстициональному образу жизни, делают очередной шаг к последующей эволюции и к жизни на растениях. Их переход к эндопаразитизму также интересен. Они рассматриваются автором как частные случаи предыдущей способности проживания в почве. Интересна также категория осцилляции. Это ключевая характеристика морфологической эволюции. Здесь он пишет о реверсивных образованиях, усилении, ослаблении различных аспектов морфотипа наследуемого морфотипа, о экспансии на растения,
formation of cryptic species complexes and convergent formation of large morphologically uniform polyphyletic genera. Wide use of confocal laser scanning
широкое использование конфокальной лазерной микроскопии позволило автору получить новые данные о анатомии четырехногих клещей. Также полезно было использование трехмерной реконструкции внутренних половых органов. Это важно для последующего сравнительного анализа. Интересные данные по сравнительной анатомии подсемейств и трибов. Интересно также ремарки о трех классов, которые перечислю на латыни. Сравнение новых данных о филогенезе Eriophyoidea с данными о сосудистых растениях позволило автору сделать вывод о том, что макрофилогенез Eriophyoidea отражает основные этапы колонизации высших растений и соответствует ключевым событиям в филогенезе хозяев. Соискатель описал в итоге 7 новых родов и 16 видов. И я считаю это очень важным вкладом в исследование биоразнообразия четырехногих клещей. Результаты рассматриваемой работы являются новыми, и они содействуют дальнейшему пониманию симбиотических отношений между клещами и растениями. Это также имеет последствия и для развития экономики и сельского хозяйства. Выводы представляются значимыми. Диссертация прекрасна по структуре. У меня есть некоторые вопросы по этой работе. Согласно подписям к рисункам 15 и 19, данные о типе хранения спермы и мускулатуры у четырехногих клещей, которые были получены соискателем, не были опубликованы. По моему мнению, это недопустимо для докторских диссертаций. Однако, я полагаю, у соискателя есть причины на это, и я бы хотел услышать его комментарии по этому вопросу. Что конкретно имеется в виду под эволюционной пластичностью? Этот термин используется в введении 3 главе и в заключении. Мне не вполне понятен этот термин. Второй вопрос. Хотя результаты молекулярного филогенетического анализа, описанного в диссертации, показывают, что 2 гипотезы на происхождение Eriophyoidea являются одинаково вероятными, все же хотелось бы понять, по какой причине автор в итоге принимает лишь одну из гипотез. На чем базируется это мнение? Пожалуйста, поясните вашу точку зрения. Третье замечание. Насколько я знаю, акариформные клещи, обитающие на растениях, как эти клещи, эрiophyoidea обычно называются фитофагами в литературе. Однако автор диссертации называет их фитопаразитами. По-моему, это не очень широко употребительный термин. Пожалуйста, обоснуйте свой выбор. В заключение хочу сказать, что соискателю удалось собрать огромный массив данных по сравнительной морфологии, ассоциациям с растениями хозяевами,
association of
данные по
eriophyoid mice with
молекулярному
vascular plants,
филогенезису
and provided a new
эрioфиоидей.
hypothesis on the origin
Интересный его
of
исторический
eriophyoidea.
обзор
The dissertation is an
развития
important contribution
ассоциации
in the problem
эрioфиоидей с
of the
сосудистыми
origin of
растениями.
cytophagy in mice. It makes a significant contribution to our
Работа
understanding of
Четверикова — это важный вклад в наше расширение понимания того, что такое колонизированная эволюция в тех группах, чья эволюция затруднена крайне маленьким размером. Очевидно, что это шаг вперед не только в расширении наших знаний о четырехногих клещах, но и в том, что автор применил новые методики исследования, и они будут в дальнейшем полезны для других исследований в этой области. Полагаю, что диссертация соответствует всем требованиям, предъявляемым к подобным работам в области естественных наук. Впечатляет объем публикаций автора, и они превышают минимально требуемое количество публикаций. Я рекомендую принять эту диссертацию к защите, и после обсуждения я рекомендую присудить степень доктора биологических наук Филиппу Четверикову. Thank you very much for the report.
Итак, коллеги, последний отзыв – это мой отзыв.
Now I'm going to read out my report. Since I'm in a very privileged situation, when a lot has been said about the thesis, I will try to be brief, and I would like to focus on the issues that are interesting to me personally. First of all, I would like to say that the thesis is a monographic description of the group of mites, and this description can be qualified as a high-level research. The research findings are published in major journals. And besides, I believe that the material which was collected by the author himself or obtained from his colleagues from all over the world also makes the thesis and the research valuable and reliable. One of the merits of the thesis, which is relevant for the doctor's degree, is the in-depth analysis of the material. He describes the issues in general biology in his thesis. He starts with the general issues and he finishes with a wide range of issues which are interpreted and described in a very interesting and informative and original way. In the first chapter, I mean in the introduction, Mr. Chetverikov writes about the eriophyoidea. He writes about endoparasitism, and there's also a very interesting conclusion in the thesis. He writes about the simple and miniature form. He writes about the morphological and functional properties of the mites. I believe that the candidate for the degree is able to solve some issues in the co-evolution of host and parasite. And finally, I cannot but mention that I like the part of the thesis which describes the cooperation, or I mean the gologenesis. This group of mites can be used as a model which allows us to understand the nature of gologenesis or the nature of interactions between different organisms. This interaction does not lead to any deaths or to any illnesses and diseases. This modification, or I would rather say this interaction, results in the modification of different bodies and organisms. I would like to highlight that he writes in detail about evolutionary trends, and each morphological and functional feature is described in the context of evolution. The phylogenetic analysis presented by the candidate for the degree has been described by my colleagues as well, but I would like to highlight the following. The phylogenetic analysis uses molecular and phylogenetic traits. Moreover, he also uses paleontological traits. Although it is not possible to use such features for the analysis, but it is possible to use paleontological traits for the group of mites that Mr. Chetverikov is studying. The thesis also discusses the spread of eriophyoids, and he suggests different hypotheses. The major hypothesis he suggests is well reasoned and substantiated, and I agree with him. The thesis also discusses the evolutionary plasticity. The author focuses on the gologenesis. There are two couple of issues I would like to highlight. Well, the population of Eriophyoidea is quite distinct and is quite unique. According to the author, different genetic types of oscillation took place in the evolution process. The structure of the population is also quite unique, and it had an impact on the evolutionary process. Professor Chetverikov has identified cryptic species. Some of them are characterized by strong genetic differences, and other species are identical from the genetic point of view, but very different from the morphological point of view. Since I'm not an expert in this particular field, I have a question. What is primary for you? The difference in genetic markers or the difference in morphological traits within the genetically homogeneous material? This is the question I would like to ask. You are writing about secondary and primary evolutionary channels, and this is a very interesting issue, and my colleagues have discussed this issue as well. It was formulated in such a way that it raises interest from the colleagues, and of course a question arises here. What do you mean by secondary evolutionary channels? So, the primary channel is the phylogenetic evolution. How can you say this, your concept complies with the concept of crioids? I believe that you did not give a detailed explanation here, and one of my colleagues has already pointed this out. And I must say that some linguistic inaccuracies in the thesis are quite rare. So this is not a general critical remark, it's probably a single linguistic inaccuracy. But the thesis is well written, and in the near future I believe you can publish a monograph. I will read out a part from my report. Well, I would like to say that there is one quotation I would like to read out, which is very poetic in my opinion. They reflect the supreme extent of failure to produce morphological novelties in a system constrained by specialization and miniaturization, and yet represent an elegant solution to avoid hyperspecialization and extinction. Full stop. I agree with this idea, but I believe that this statement should be reworded. And another critical remark, which is not in my report, but I would like to highlight it. I'm asking you about the morphospace. So, do you have any comments about the limited morphospace in this respect? So, in general, I would like to highlight that the thesis uses original data collected by the author. It is relevant from the theoretical and practical point of view, and it opens up possibilities for studies in such areas as zoology, parasitology, and evolution. And the thesis is easy to read as well. And here I agree with my colleagues, and I think that Filipp Chetverikov can be awarded the academic degree of the Doctor of Biology, because the thesis complies fully with the requirements for the thesis of the doctoral degree. Thank you. Since this was the last report, I would like to give the floor to Mr. Chetverikov. Please answer the questions. Start from the external reviews and then answer the questions that are in the internal reviews.
When I was preparing answers to questions, I read all the reports thoroughly and then compiled this table. Here we see which critical remarks I found there and which of them had questions. Galaktionov wanted to explain the use of terminology in the third chapter. This is about channel trends in the evolution of eriophyoid mites. The terms in question are trends, aspects. I suppose I should have used the term aspects here. Maybe there are a couple of pages in my thesis which still use the old term modus, which I discarded. The next question is by
Александр Анатольевич
Mr.
указывает
Stikolnikov.
необоснованность утверждения о том, что участие щетинок в локомоции и расселении – это результат адаптации.
He says that sati in the locomotion of plants is irrelevant. I focused on the three groups of features: adaptation to phytoparasitism, features which are not anyhow connected with phytoparasitism, and the third group is a different one, and I made a misprint, and this set term was put in a different group of features. The next question is the Emerine system about homoplasticity. This is a working system, but there are more and more cases when the system is no longer satisfying. Maybe this is the inaccuracy in my wording which created this misunderstanding. Alexander is interested how I chose in-groups and out-groups for cladistic analysis. I introduced those groups which were related to eriophyoides before. Non-relatives were excluded. We didn't include diomedicides because currently there is evidence that they are really distant relatives of eriophyoids. There could have been some false reasons to regard them as related due to their body shape. Even if when these features of body shape were excluded from the morphological analysis, still this clade remained, and we found some features which that allowed us to regard this group as similar. There are works which provide evidence that eriophyoids and acariformides are similar. A recent publication by Pipatov and Klimov focuses on water mites. It has an interesting molecular analysis. I suppose that reviewers had the same question, and they provide some mathematical calculations to stand for their viewpoint. Stikolnikov also shows that vermiform body may be the result of ancestral endoparasitism. I discussed this hypothesis in one of the articles I published some years ago. My conclusion was that this hypothesis is against the cases of endoparasitism among Eriophyoidea. If you look at the phylogenetic tree of eriophyoid mites, in cases of transfer to endoparasitism, this is only witnessed in the most evolutionary advanced trends. This is not present in basal groups. It's a secondary phenomenon. So we can't say that it's an ancestral feature. Then Stikolnikov speaks about heterogeneity of the material for molecular phylogenetic analysis. Here, I disagree with the colleague. What we see in many manuals these days, the author of this hypothesis states that his thorough analysis did not allow to determine any synapomorphy. The novel data I have provided, morphological data in particular, allows to state that my hypothesis is the leading one because there is more evidence behind it. Still, in my dissertation, I write that this is still an open question. However, there is more and more data in support of this hypothesis, and I will give some more evidence for that later on. Maciej Skaratsky is interested why some of the data was not published. I think what you refer to as here is refers to type of packaging sperm and spermatex. When I was submitting my thesis, it was almost a year ago. This data was not yet published. It was published a bit later. So anyhow, this small part of the data is already published. No less than 95% of the data has been published, which is enough. The next one is the question about evolutionary plasticity. What do I mean by evolutionary plasticity? It's adaptive potential of a group and its implementation in evolution. I understand why you asked this question about phytoparasitism. Parasites are often referred to as blood-sucking mites or invertebrates. Eriophyoidea is a typical obligatory parasite, phytoparasite. Their life cycle starts and ends on plants. They feed on plants as well. The next question and the following remarks are by Mironov. He has provided many critical remarks. The first one is about the tables and illustrations which are given in the end of the text. It was a recommendation I got from some of the colleagues. This is why I followed this structure. As for the methods and materials, I agree that they are given only briefly, but I find them enough to understand the methods I used and materials I used in my thesis. Anyway, this is open source data, so if it needs clarification, you can refer to these sources. The next question is about the reduction of the posterior pairs of legs and the vermiform body. In embryogenesis, Eriophyoidea leg, the pairs of legs 3 and 4. The next question is about the reduction of segments, and that it's commonly known. What I meant in my thesis is something different. The thing is, if legs 3 and 4 are lacking, then it's not clear if metapodosome segments are still there or not. And we provide some evidence that they are still there. They're cone-shaped, they're reduced at the back, and still there at the front. According to Shevchenko, Delio, and Notsachi data, the digits are cube-shaped, and there we find the so-called motivators, and there are muscles there, and these digits
Еще один вопрос о
work
возможности
in
оплодотворения
turns,
матерей
and this is
сестер,
how they
сперматофорных
pierce
сыновей и
the
братьев и
tissue.
клещей в ходе инбридинга. Поэтому вопрос
The next question is about inbreeding.
лет 20 назад был
Eriophyoid
описан
mites
оренотокический
that was
партеногенез.
described some 20 years
Самки
ago.
эрiophyoidеи уходят зимовать оплодотворенными.
Female
Они откладывают яйца,
mites
из которых выходят самки, которых уже некому оплодотворить. Соответственно, из их яиц выходят только самцы. Дальше эти самцы
can only
откладывают на листе сперматофоры,
produce male mites,
и эти сперматофоры
after
могут выбираться
dormation,
как матерями, так и бабушками, если
and
они
then
проживели
spermatophores
А следующая волна
can be produced by
размножения
mothers
братья и
or
сестры могут получить
grandmothers,
сперматофоры. То есть это
and the
пока.
next wave is that brothers and sisters can produce spermatophores.
Ну и, наконец, Сергей Валентинович в отзыве упоминает об одной свежей работе, которая противоречит нашим данным
Then
о развитии
Mironov
исключенных
mentions
Мне
a
работа
recent
эта
study.
известна. Это тезисы постерного
I'm
доклада на
familiar with this
последнем
study.
морфологическом конгрессе.
It's a poster
В этой работе
report
приведены данные только
at
по одному
a
гену.
latest
При этом большая
congress
часть данных
in
это из нашей
Acari.
работы 17-го гена, в которой
Most of the data they used is taken from my study.
работе Я думаю, что
They focus on 6
дождаться
genes.
опубликования статьи.
Before
Ну,
we
кроме того,
make any conclusions,
позвольте мне
let us
повторить,
wait
что
until they
появляются
really
новые
publish
данные, которые
their
согласуются с
paper.
нашими выводами, в частности, я
And
имею
as I
в
said,
виду
new data
статью
is
австрийских
appearing,
коллег Шаффер
which
и с авторами
is in line with our conclusions.
По их данным, эрiophyoidea не попадает в группу
There is some data that Eriophyoidea is not thrombotiform mites.
И теперь два вопроса из отзыва
Two questions from
Конституционного совета.
the report of
Андрей Игоревич спрашивает,
Chairman,
какими критериями я пользуюсь
Professor
в
Granovich.
своей работе.
The first
Должен
one is
признаться,
about the
что
criteria
решение
used in the
различных задач каждому оказывается
taxonomy.
разное. И так написание,
That depends.
например, фаунистического
To
разнообразия,
describe
безусловно, удобнее
fauna
таксоны с
diversity,
морфологическими различиями.
it's more convenient to use taxa with clear morphological differences. If we focus on sophisticated relations with pathogens, we have to keep in mind haplotypes and cryptic types of minds. This is an applied study. The second question is about secondary channels. The question is, can we regard them as dominating cryoids, likely to what Oddington did in his studies? Secondary channels, in my understanding, is the same regularity based on different material. This is what Oddington wrote about, talking about cryoids. I illustrated that. So there is a valley, there are different rivers which form this lake. So a lake is a secondary channel or a cryoid. The final question is from the external review from Geza Rybka, professor from Hungary. The professor is interested about the status of Eriophyoidea in basal divergence. The segment colored yellow should leave the Eriophyoidea group. Bocek introduced Phytoptidae and Eriophyoidea terms. I have many doubts about Diptera myopid family. There are more and more issues and questions around these family. Soon we will have to break up this family. Thank you. I hope I have answered your questions. Please take a seat. Maybe we have some board members who disagree with some of the points, and now it's time for a Q&A session. any of the non-board members are welcome to take the floor. Still, if any board member is willing to take the floor, if they disagree with what the candidate stated, you're also welcome to take the floor. So is there anyone present who would like to make a comment? Could you please use the microphone and introduce yourself? I have been working in close collaboration with Chetverikov, and I'll be brief. Chetverikov is a very experienced scholar. He started working on eriophyoid mites when he was still at school in the 9th grade. So this is something that is telling of his immense experience. I'd like to speak about his advantages as a scholar. In many reports we heard today, we heard that he has made a major contribution into the studies in eriophyoid mites. He is the one who never stops on his way to achieve more in what he does. He is able to state questions and to provide answers to questions. He has an inquiring mind. I evaluate his work really highly. He has provided many answers to many questions, and at the same time, his study has given rise to many more new questions, and he is still making effort into providing answers to them. What do many people do? They collect data, write thesis, and then defend it, and this is where they stop moving forward. But Chetverikov is a different kind of scholar. There is much to be done in future to focus on how this group of Eriophyoidea is related to other groups of mites. Many of the relatives are not those who populate plants. We see their relatives in soil and in sand. Linguist just had to do that. He didn't have any other choice. He doesn't have much evidence, and we see this now according to the results of molecular analysis. So this is a promising study. You have done a good job of analyzing mouse parts. On the other hand, inside the group of Eriophyoidea, there is a detective story. There is a range of questions there. What's going on there? Filipp, could you please show again that picture with channels? The thing is, what do we see here? Due to all the works in this area, including Chetverikov's study, we have a general understanding of Eriophyoidea on plants. I'll skip the evolutionary picture. There are groups which have plesiomorphic features. These are those which populate coniferous forests. What do we have next? We have a powerful wave of Phelicopters and Eriophys. Those don't have plesiomorphic features. Then there is expansion on gymnosperms. Then we see Goller genesis, and the next step is populating plants.
So what are the morphological differences? They have a different setae. Their setae are situated in a different way. However, we did not take into account these features. Why did this happen? So then we have a new wave of evolution, and it also deals with gologenesis, but here the gologenesis is of a different type. And the second wave gives way to different processes. Here I mean very small, very miniature mites which live on crops and on gymnosperms. Why did it happen? We don't know. It is not quite clear yet. The species are related. Morphologically they are very similar, but on the other hand they are very diverse and they are different. So these are the issues I hope you will be dealing with in the near future. And I support Mr. Chetverikov, and I believe the thesis is very interesting. And Mr. Chetverikov should be awarded the academic degree. The thesis makes a great contribution to the acarology. Thank you. Is there anything else who would like to take the floor? You may ask questions if you want to. Okay, so since there are no people who would like to ask questions, please make comments about the presentations that you have just heard. I would like to thank you for your high evaluation of my thesis. I agree with your comments. I believe, yes, I understand that the thesis raises many new questions, and I am planning to continue my research. Okay, let's have a small break. Please, I would like you to ask the room, and only the board members can stay in the room. Please don't go too far, and please stay somewhere nearby, because our discussions will not take too much time, and please switch off the broadcast. Okay, the members of the dissertation board are staying in the room.
Colleagues, please take your seats. We are proceeding with our agenda. Please switch on the broadcast. Make sure that there are no technical issues. Make sure that we can see and hear each other well. It's now the highlight of the session of the Dissertation Board. It's a formal procedure. It will take some time. I put for voting the issue of conferring or non-conferring the academic degree of the Doctor of Biology. Let me remind you also that the decision of the Dissertation Board on conferring the academic degree is positive, provided it has received 50% of the votes from no fewer than 3 members of the Dissertation Board. It's now time to hear the opinion of each of the board members and then to give our final conclusion on conferring or non-conferring the degree. So what is your opinion? Are you voting for or against?
Да, я согласен.
I'm voting for. Thank you. Galaktionov, are you voting for? Yes, it confirms to all the requirements set forward to such works. What about you? Yes, I'm also voting for. Professor Skaratsky, are you voting for conferring the degree of the Doctor of Biology to Chetverikov?
Of course, I'm voting for.
Конечно же, я голосую за. Okay, thank you.
И как последний член диссертационного совета я не присоединяюсь, но отдельно голосую за.
I'm also voting for conferring the academic degree to Filipp Chetverikov, degree of the Doctor of Biology, specialization zoology.
У нас при подсчете голосов весьма сложном не возникло никаких сомнений. Совет единогласно.
It wasn't difficult to count votes. The decision is unanimous. Every board member has voted for conferring the degree of the Doctor of Biology to Filipp Chetverikov. Nobody has voted against or abstained from voting. So, Filipp Chetverikov can be conferred the degree of the Doctor of Biology. According to the agenda, now it's time to give the floor to Filipp Chetverikov for his closing speech. Colleagues and friends, I'd like to thank each and one who has been facilitating me with my research. I'd like to thank Suferev, and I'd like to thank my school teacher. It was she who introduced me, so to say, to this family of eriophytes, and then she was my academic supervisor. I'm really thankful to Andrei Bochkov. He was my opponent at the Institute of Zoology. We had long sessions discussing the results of my studies. He was a brilliant scholar. Unfortunately, he's deceased now, but he's someone I will remember all my life. I'd like to thank my colleagues, Galina Konechная, Irina Dadueva, from the Department of Genetics of St. Petersburg State University, who helped me to collect valuable genetic material. I'd like to thank my international colleagues, James Emerine from the USA. He is the author of the recent classification of eriophyoids. We have been to field trips together, and I hope we have more trips in future. And I'd like to commemorate my senior mentors I was lucky to be the student Valery Shevchenko, Evgeny Ninburg, and Alexei Gilarov. If they were here today, if they could make it to be here today, they would be really happy to listen to the results of the research. Colleagues, this is the end of our agenda, and this is the end of our session. I'd like to thank everyone for joining us today. I'd like to thank Professor Skorotsky. Matej, thank you very much for joining us. So please switch off the broadcast. Thank you.